starting live.
Hello.
Speak.
Good evening. Welcome to Mrs. Spencer's Math Lab. Thank you for coming in to see it. If this is your first time, I really extend a great welcome to you. And if it's your second time, I'm glad you returned. While I am getting started, I would like for everyone who's being tutored to get pencil and paper, because this is not a lecture at all. You have to be involved in what you're doing. And what I want to stress is what we stressed last week. Math is fun. Math is not hard. And you can be successful. These are the kinds of ideas I want you to get in your head as you approach mathematics. Many times we have a negative view of it. And if we have that negative view, we're not going to do well with it. So how can we be successful? First, learn the concepts and use the concepts. Practice, learn the language of math, learn the processes, and study. And I want to make a difference between study and homework, as I did last week. Homework is what your teacher gives you to do to practice what she has taught you, to see if you've learned it well. Study is what you do on your own, reviewing the processes, reviewing the language, reviewing all the techniques that you have learned. And so that you too can see what you have learned and if you have learned it well, so that you can have good questions to ask your teacher. And on the matter of questions, I want to say, never be afraid to ask a question. The only question that's wrong is the one that you didn't ask. So ask questions, because no one will know what's bothering you unless you do this. So let's say that you have your pencil and paper now, and we can get started. As you see, fractions is the title of our lesson for tonight. And I want you to think of fractions as being fun. Fractions as being fun, not as something I just hate, something I just can't do. Fractions are your friends. And the concept that we want to work from, first of all, because tonight we're going to be adding and subtracting like fractions. So the concept that I want to go with you first is only like quantities can be added or subtracted. Remember from last week I asked you how much was 3 dogs and 2 cats? And of course most of you probably said 5. And I told you that was not a good answer, because I told you what I was adding. So you have to tell me what the answer is. So it has to be 5 animals, 5 four-legged creatures. So we have made them alike, and now we can add them. The same is true for everything that we add. They must be like quantities. We don't add feet to miles, miles to inches, and inches to feet. We have to have one unit. So the next question is, when are fractions alike? Fractions are alike when their denominators are alike. So let's go to the board for a moment. All right, first of all, what is a fraction? All right, a fraction simply is a part of something. It can be a part of your body. It's a fraction of my finger, it's a fraction of my body. It can be a part of something you're eating, a pizza. You cut it in slices, and each slice is a part. It can be part of a geometric figure. It can be a part of anything. So it's a part of something, okay? My goodness, my handwriting is terrible. All right, it's a part of something. All right, so let's look at the parts of a fraction. A fraction has a denominator, a numerator, and a dividing line. All right, so those are the parts of a fraction. So let's take an example. 3/5. That's how we read it. Okay, the denominator is this part, the number at the bottom of the fraction. The numerator is this part, the part at the top. And the dividing line, which you see here. And I'm going to put a little mark by this because we're going to really see that that means more than just something that divides the numerator and the denominator. It actually expresses division, but we're not going into that tonight. All right, so we have the numerator, the denominator, the dividing line. All right, so this, what does this tell us? First of all, the denominator tells us how many parts are in the whole. So as you look at this fraction, how many parts are in the whole? I hope you said 5. And how many parts are being used? And I hope you said 3. All right? So we have a numerator and a denominator. So I want you to write for me a fraction that has a denominator of 8 and a numerator of 2. Okay, I hope you wrote 2/8. All right, let's write a fraction that has a numerator of 6 and a denominator of 12. And I hope you wrote 6/12. So, in this fraction, how many parts are in the whole? 8. How many parts are we using? 2. In the other fraction, how many parts are in the whole? 12. How many parts are we using? 6. All right, so this is how a fraction looks, and this is what a fraction tells us. So, if I ask you to draw me a rectangle, on your paper, draw a rectangle. This thing is so slippery. And divide it into 4 equal pieces. What would be the denominator of this? If we were going to do any fractions, what would be the denominator? So we count the number of parts. 1, 2, 3, 4. So the denominator is 4. Each part is 1/4. 1/4. 1/4. 1/4. All right, so if I used 2 of these parts, 3 of these parts, let's use 3. Write the fraction, write the numerator of the parts being used. And you should write a 3. All right, so if we're going to add fractions then, the first thing we're going to look at each time is, are the fractions alike? I cannot add or subtract unless the denominators are alike. All right? If you have questions, you can do them on the Facebook site, and I will see them. All right, from here, let's go. Suppose, for example, I had a fraction. I have 12 boys. Let's see who can get this. 12 boys and 5 girls. And I want to know what fraction of this class is girls. Now I'm going to pause a minute because I want you to figure it out before I give you the answer. Now remember, the denominators have to be alike. That's a principle that you got to remember each time, because that's the only way we can work with fractions if we add it. But to write this fraction, all you need to know is the denominator and the numerator. So what would the numerator be? So I said the fraction of girls. How many girls are there? 5. All right. And what should the denominator be? I hope you're not saying 12. Because remember, the denominator would be the whole class. And so the class consists of 12 boys and 5 girls. So that makes 17. So the fraction of girls is 5/17. 5/17. What then is the fraction of boys? And I know that's easy for you now. That's 12/17. All right, so remember, the numerator tells the part that you're using or expressing at that time, but the denominator has to be the entire thing. So the entire class here is 17, not 12. So I hope you didn't say 5/12. So if you did, let's not make that mistake again. All right, let's see if we can add some fractions now. So reviewing quickly, fractions are part of a whole, and that contains a numerator, which is the top number, the dividing line, and the denominator. The numerator tells us how many parts are being used. The denominator tells us how many parts are in the entire thing. So let's see if we can add 3/7 plus 2/7. All right, easy enough. Now, we said that we are not adding the denominators. Why? Because the denominators don't change, because they are already alike. They don't change. The only time we need to change them is when we have unlike fractions, which we'll work on next week. So, model what I do. So I'm going to go over here, put the line, and I'm going to write the denominator. That's 7. So always go ahead and write that. And then the only thing you got to do now is add 3 plus 2. So the answer is 5/7. 5/7. And that's easy enough. All right, so basically, what is the process? The process is first, see if the fractions are alike. And if they are alike, then write the equal sign, put the denominator, which both of them have to have, and then add the numerators. Simple enough. There's one more step that we're going to do today with this after we just add a few. All right, so let's do a few more. 7/8 plus 3/8. Are the fractions alike? Yes. So we can write that denominator and add 7 plus 3, and we get 10. Now we haven't finished this because this is not the last step, which is simplify. In math, the last step is always simplify. In other words, give the most simple answer. And sometimes they call this reducing. I don't like to call it reducing because it gives you an idea that it's smaller. It's equivalent. It's the same size as this. It's just expressed with smaller numbers. So we're going to make that clear. So we're not really reducing a fraction. We're just rewriting it in its simplest form. And that's what we call simplifying. All right, so we could add a lot of those. I think it's simple enough. Going back over what we do, if we first observe to see if the denominators are alike, and if they are, we can rewrite that denominator and then just add the numerator. And the last step is simplify. All right, so let's talk about how we simplify fractions. All right, I'm going to put a fraction up here. I'm going to put 5/10. And we're going to talk about that. It's a simple one and one of the easiest types to do. All right, what we want to do is to look at this. And I'm going to give you a word which you need to use, which is called factor. Factor. Factor is a number that is multiplied to give you a particular sum. A multiplied product, I'm sorry, that is multiplied to give you a particular product or number. We'll say number at this time. All right. So, for example, if I have 5, what numbers can you multiply to get 5? 1 times 5. This is all, okay? So its factors are 1 and 5. 10, what are its factors? Okay? It's 1 times 10, 2 times 5. Are there any others? Well, I'm going to tell you something that will help you not to even waste time doing that in a moment. All right, so what are the factors of 10? 1, 2, 5, and 10. Because every number is a factor of itself with 1. All right, so which factor is the same in each one of these? Okay, of course 1 is, and that doesn't count because 1 never changes. If we multiply anything by 1, we're going to get that same number. So we don't count that as it can be a common factor only when the fractions are already reduced. And I'm going to give you an example of that. So which one does both of them have? And what is the largest one? Both of them have 1s, and both of them have 5s. Now, which is the largest? The largest is 5. All right, so what we have done is just found what we call the greatest common factor. All right, the greatest common factor. And I'm going to write that on the board in a few moments. All right, so what are we going to do to reduce this fraction? All right, I'm going to write it over. 5/10. All right, I'm going to divide 5 and divide this one by 5. Remember, in you dealing with the fraction, whatever you do to the numerator, you have to also do that same operation to the denominator in order to keep it equal. All right, 5 divided by 5 is 1. 10 divided by 5 is 2. Now, if you can't divide yet, you could have gotten it right from here. Because this one, here's the 1. And this one, here's the 2. So you could look at it and almost see if you can go that far. All right, so let's talk about greatest common factor. I'm probably erasing this too soon. The greatest common factor, again, is the largest factor. Greatest is largest. largest or biggest, if you want to use that word. Common means that both of the numbers have it. It's a factor for both of the numbers. Okay? And factor, we've already defined as a number being multiplied to get another number. All right, so we call that for short the GCF. GCF. So let's practice first finding some GCFs. Let's practice finding some. All right, suppose I had 4 and 8. All right, see if you can find the GCF for a moment. All right, what you're going to do is find the factors of 4, find the factors of 8, find the largest one. And then I'm going to give you a clue, too, that will save you some time. All right, we know that 4 is, always start with 1. 1 times 4. And 2 times 2. Okay. 2 plus 2 is 4. Okay. All right. And so the factors of 4 are 1, 2, and 4. 1, 2, and 4. All right, let's do it for 8. 8 is 1 times 8. 2 times 4. All right, can we get any more out of those? All right, so we have for 8, we have 1, 2, 4, and 8. Those are the factors of 8. Now, which ones do both of these have? Both of these have 1. Both of these have 2. Both of these have 4. Which is the largest of those? The 4s. Right? So that means the greatest common factor of 4 and 8 is 4. So we're going to divide 4 8s by each one by 4. It's getting messy. Let me move this over a little. Okay. So we can go right here and find it. Well, for 4, it's what? For 4, it's 1, okay? And for 8, it's what? 2. So the answer is 1/2. All right. Let's do some more. Without adding, I just want you to take a moment and see if you can find the greatest common factor of some numbers for me. Okay. So we're going to call it, we're going to nickname it GCF. All right. All right. A 4 and 3. Find the greatest common factor of 4 and 3. That's number 1. Number 2, the greatest common factor of 6 and 12. All right. 3, let's get some larger ones. The greatest common factor of 16 and 20. All right, I'm going to give you a moment to work. And as you do, I'm going over the process. Find the factors of each number and then choose the one that is the greatest. Then divide each one by that particular number, and you will have the fraction in lowest terms, which does not mean that it's less. It's not really reduced. It's expressed in lowest terms. But whatever answer we get is equivalent in a fraction when we're doing fractions is equivalent to the original fraction. I want to make that clear. All right, what did you find for the first problem? All right, 4 is 1 times 4 and 2 times 2. Okay, and that's for 4. And 3 is 1 times 3. What is common? Only the what? The 1. Okay? So the greatest common factor of 4 and 3 is 1. Okay? So that means if you had that in a fraction like 3/4, always test it to see if there are any common factors, but other than 1. So if it's only 1, then the fraction is already simplified. So let's remember, if two numbers or two denominators have only 1 as a common factor, then that fraction is already in simplest form. If any fraction has only the 1s as the greatest common factor, then they are already simplified. And I want to stress that. All right, let's look at 6 and 12. What did you get for that? Did you get 6? I hope you did, but let's see how we do it. So let's look at 6. 6 is 1 times 6, and also 2 times 3. So the factors of 6 are 1, 6, 2, and 3. And factors of 12 are 1 times 12, 2, see I'm just going right up, 1, 2, 3, 4. All right, 2 is 2 times 6, and 3 is 3 times 4. And then if I went up to 4, I've already said it because it's 4 times 3, and I don't need to write it over. Because 4 times 3 is the same as 3 times 4. All right, so let's look at the factors. All right, they have 1 in common. They have 2 in common. Okay. All right, they have, what else in common? 6 in common. And 3 in common. The only one that they don't have in common is the 4. But what is the greatest, the largest? And the largest is 6. So for the 6, then if we were doing fractions, then this fraction would be 1/2 if this was 6 over 12. Because here's the 1 by the 6, and here's the 2 by the 6 here. All right, now for 16 over 20, I thought I would put a bigger number up here so that you could see. So let's do 16 over 20. All right, for 16, I'm going to draw a line here because some of you may be writing this down. All right, for 16, it's 1 times 16. Notice I always start with 1. 2 times 8. I'm going right up. 1, 2, 3. 3 is not a factor of 16 because there's nothing we can multiply 3 by, a whole number, that would give us 16. So 4 is 4 times 4, which is 16. All right, 5 won't do it, 6, and so on we go. All right, and let's see for 20. All right, 20 is 1 times 20. Notice I always start with that. If you get a system, you'll always do that. 2 times 10. Okay. 3 will not do it. 4 times 5. And next number is 5, but we already got that. So you know when you're finished, because if you start to get the same numbers again, then you know you have finished getting the factors. All right, so what are the factors of 16? 1, 16, 2, 8, and 4. What are the factors of 20? 1, 20, 2, 10, 4, and 5. All right, what are the like factors that each had? They have 1s, they have 2s, they have 4s. All right, any others? All right, 20 is too big for 16, 10 won't do 16, 5 won't do 16. It has to be common. Both of them have to have it. 8 will not do 20. All right. So what is the largest of the common factors? The largest of the common factors then is what? 4. All right. So what will we do with that 4? All right, so this is for 16, and this is for 20. So we have 16 over 20, or 16 20ths equals, and we have for 16, 4, and for 20, 5, 4/5. All right, is that simple? Yes, because there's nothing, and a factor of 5 is only 1 in itself. So that will now, that we know that that's simplified. All right, so are we getting that? Because that's the last step whenever we are doing fractions, is to simplify. So notice today all the fractions that we are doing are called improper fractions because the numerator is smaller than the denominator. We are going to also talk in another week, because I don't want you to get confused, on what happens when the 20 is on top and the 16 at the bottom. When the 20 is the numerator and the 16 is the denominator. But today we won't do that. All right, so let's do some fractions then and see if we can find the greatest common factor to reduce them at, or simplify them at the end. All right, let's see if we can add 3/12 plus 5/12. All right, the first thing we want to do is to see if the denominators are the same, and they are. So we can now just write that denominator. Hope you're doing this with me. And the next thing we want to do is add the 3 and the 5. 3 plus 5 is 8. All right, now the last step is to simplify that fraction. Check it to see if there are any factors in there that can make the numbers smaller, but it's still going to be the same equivalent or same size fraction. 1 times 8, then 2, and you fill it in. 2 times what? Okay, 4. 3 won't do it. 4, we already have 4, so we finished with the 8. Let's do the 12. 12 we've done before. It's 1 times 12. 2 times 6. 3 times 4. 3 times 4. And 4, and we already got the 3 there. All right, so we finished. So when the numbers start to repeat, you know you have all the factors. Be sure you get them all. Because when you get to larger numbers, If you just get 2 or 3 of them, you may miss the greatest common factor. So don't make that mistake. All right, so let's see if you can take a moment and tell me what the GCF is, the greatest common factor is. And I hope you said 4. All right, so here is for the 8, and here is for the 12. So for the 8, what goes at the top? What's beside the 4? 2. And what goes beside the 12? In place of 12? Let's see. 4 to 12, 3. All right, here's the 3. All right. So I hope it's helped you, because I have tried to point to you how you can figure it out and won't have to go back if you just list them. Another way teachers teach it is that they just list all the factors, and you can do that. And I'm going to do one and do that so I can show you what is done there. It depends on which level you're on as to which one you use. All right, suppose you had a fraction. Let's see, a good one. 14. Oh, I don't want to make it too big. Just say 14/20ths, just to give you a little more practice. All right, so we have 1 times 14, and I'm going to put it over here because that's going to be the largest one. All right, we have 2 times 7. All right, 3 won't do it. We can add all the 3s we want. We get 7. We add 3 plus 3, that's 2 of them. That's 6. And so on. And we'll go on and we'll get 12. But we add another 3, you're going to get 15. So that's too big. All right, so 4, no. 5, no. 6, no. 7, already have it. So I'm finished. So the factors of 14 are 1, 2, 7, and 14. All right, factors of 20. Factors of 20, 1, 20. Now I'm doing that because 20 is going to be the biggest one, of course. 2, 10. 3, no. 4, yes, 4. And 5. 6, no. 7, no. 8, no. 9, no. 10, we already have it. So we finished. And notice I went right until the numbers start to repeat. That makes me know that I have all of the factors of 20. All right, so now we look at the ones that are like the 1s, the 2s, and what else? That's it. Which is the larger? 2. All right, so 2 for 14, we divide it by 2, we get 7. And for 20, we divide that, we have to do the same thing to both, by 2, and we get 10. So the simplification, or the slowest form, or the simplest form, or the reduced form of 14/20s is 7/10. All right, now what you need to do is take what you have written down and go online and get some examples and use those examples, and you first study what we have done so far. Go back over it and then try some examples on your own and see how well you do. So let's review for a moment before I go any further. All right, we started out saying only like quantities can be added or subtracted, and we're going to do some subtraction in a minute. Only like quantities can be added or subtracted. All right, when our fractions are like, when their denominators are the same. All right, So what are the parts of the fraction? The numerator, which is the number at the top that tells how many parts are being used, and the denominator, which is at the bottom, which tells how many parts make up the whole thing. All right? And then the dividing line. It divides them, and a little later I'm going to tell you what else it does, because it's a part of division, but we won't go into that today. We don't need to do that today. All right? So when we add them, we first look to see if their denominators are the same. If they are, we write the equal sign, write the denominator over, because I don't want you to ever add those. It's just like adding 2 boys plus 2 boys. It's 2 boys plus 2 boys is 4 boys. Boys. It's not boys, but boys. So it's the same thing here. All right, so we add the numerators and then we simplify. How do we simplify? We first find the factors, which are numbers that are multiplied to give you the numerator, and the numbers that are multiplied to give you the denominator. And I suggest just starting from 1, 2, 3, 4, 5 times something until you all get them all. How do we know we have them all? It starts to repeat. So we don't want to repeat the same number over and over again. All right, I showed you 2 ways to get the greatest common factor. Just list them as I did here. The other way was to show it with the multiplication. 1 times 14, 2 times 7. And here for the 20, it would be 1 times 20, 2 times 10, 4 times 5. All right, whichever method you want to use will get you the same results. Be sure to simplify. Lots of times on a test, that's what you get marked down for. And some tests only give you credit for having the fraction in the reduced form. So let's be sure we do that. All right, I hope you have understood how to add like fractions. We're going to do a few subtractions. And our concept for today is only like quantities can be added. We are adding fractions today that are alike, and they are alike because their denominators are alike. All right, let's see how you would do with this one. Okay, that's number 1. Number 2. Okay, and number 3. All right, and I didn't make them difficult because I want you to get the process. Remember, we check the denominators, see if they are the same. If they are, then we write the equal sign, write the denominator, which is common to both fractions, and then subtract the numerators and simplify by finding the greatest common factor of each of the numerator and of the answer in the numerator and the denominator. So I'm going to pause for a moment and give you a chance to work on it, and then we'll see if our answers agree. I hope you are getting this, and if you're not, you can text me and tell me what you want me to go over. And if you have some things that you would like for me to discuss on tutorial nights, that you may also suggest them, things that your children are having problems with, or if you are a child listening, things that you are having a problem with, and I would be happy to include that in what we do. As a tutor, that's what I do. I work with finding what's blocking a student, finding what it is that they don't understand. Sometimes it's the language. Sometimes it's the process. Sometimes they just don't have the concept. And that's what I do. I can watch them when I'm one-on-one with them because I'm working and they're working and we share what we are doing, and then I can find exactly what's blocking them. In this situation, I cannot do that because I can't see what you're doing, but you can see what I'm doing. So if you're interested in private tutoring that can be arranged, let me know. It's negotiable, no one is turned away. It's not a money-making process. It's something to help you, and I hope that this will help you. There are many things, concepts that I have worked with students on because they were just didn't know what they were doing. And I removed that blocker, and then they don't need me. They're good to go for the rest of the time. All right, so let's see what you got for these problems. Okay, are the denominators alike in number 1? Yes. What is the common denominator? 12. 8 minus 4 is 4. Factors of 4 are 1, 2, and 4. Factors of 12 are 1, 2, 3, 4, and 12. All right, what is the greatest common factor? 4. All right, 4 times 3 is 12. So a 3 goes here. And 4 times 1 is 4. So the answer is 1/3. Did you get that? If you did, let me know. All right, what did you get for number? I didn't mean for this to happen, but what did you get for number 2? It's the same answer because 5 minus 2 is, let's write the denominator first. 5 minus 2 is 3. All right? And let me tell you something. The greatest common factor is never going to be larger than the smaller of these two. And in today's case, the smaller of these two, the numerator and denominator, the numerator is always smaller in the proper fractions. All right, so I know that 3 is 1 times 3, and I know that 9 is 3 times 3. All right, so here it is, 1/3. All right, I didn't plan for those answers to be the same, but it turned out that way. All right, and for our last problem, what did you get? Did you get 2/10? And 2/10 equals what? 1/5. All right, so I hope today you have listened and learned. And if you have questions, as I say, shoot them out to me, and I'll be happy to answer you. And it's been a pleasure working with you today. Fractions are your friends. So till next week, we're going to deal with the fractions that have unlike denominators. Can we add them? Yes, but the denominators must be alike. So I'll see you next week on Tuesday Tutoring.